So this is probably going to be the last video on nested radicals in this series. And what I'd like to look at is one last special case of nested radicals, and that would be nested radicals of this form up top. And this is one of the easiest forms to work with, and the proof behind how to get the value for x here is actually one of the simplest. And this can be done by starting with this expression using the basic idea of recursion that's been used in the previous videos. And here what we notice is that we have our definition of x, and x occurs inside the radical, so that allows us to yield this expression up top. But what's very easy to notice is that we can only get one solution for x, and that is going to be the solution of x equals c. And that's pretty easy to notice. So if we let x be equal to c, we get c is equal to the nth root of c to the n minus c plus c. Now, the plus and the minus cancel out here, and we get c is equal to the nth root of c to the n. And, well, we know that this here is just equal to c. So we get a true statement, and we can conclude that therefore c is equal to this nested expression. Whoopsie there. And we conclude that c is equal to this nested expression here that we have. Fairly nice and simply. Because, well, before I move on, I'd like to show some examples of that. So this here is for this expression that I started off at the top with. And this is for values where c is equal to 2 and where n runs from 2 to 4. And these are just some quick examples, and you get some pretty interesting ways to write the number 2 up here, which is nice. Now, one last thing that I'd like to look at in this video is some integrals that have to do with nested radicals like this. And I've already assembled what I'm going to do. I'm just going to walk through it here. And what's going to be done here is I'd like to just go over one integral of a nested radical, and I'd like to show that if you have an infinite number of radicals here, it actually becomes easier to integrate than you would if you had a finite number of radicals in this sequence here. So to start off with, we're going to be looking at this integral here, and we're going to be trying to find its solution. Using what was known in our previous video, we can show that this section in here is just equal to this piece in here. Since we know that, we can simply do our integration on it. And the first thing that we're going to do is, since we have a plus in here, we're going to break this up into two fractions, like this. So we have our first part, which is going to be by squared over 2, and then it's going to be plus this section divided by 2. Now, this bit here over 2 is very easy to integrate, and we can just take the antiderivative here using the power rule, and we get that simple section. So we have about half of the integral done now. Now here, we have to find a way to manipulate this to make our integration a little easier. So we'll start off by taking this and noticing that it can be written like this. So now we have a majority of what we're going to be working with inside the square. So we can deal with that rather simply. Now what we're going to do is we're going to do a u substitution. And we're going to say let u equal 1 plus by over root 4a squared, which is this piece in here. Differentiating u with respect to y, we get this value. And then rearranging, we notice that dy is going to be equal to 2a over b squared y du. So then using that, we can simply just swap out our substitution for u, and we get u to the half because our square root is just a half power here. And we multiply by our coefficient on the outside, which was this piece within the u, the dy. So now we have this very simple piece to evaluate. And using our power rule again, we can get u to the 3/2 here as part of our coefficient. And we get another c squared. I mean c2 as a constant. So now we just simply switch out u for this piece up here. And we notice that we get this expression here. And we just sum up our constants and we get a c value. Now, simplifying these roots here, we can get a nice simple answer. Which I will pull down here. So, as I was saying earlier, we can simplify this by just noticing that the square root of 4 is 2, and we can pull out those factors here onto the outside to simplify our roots. And that gives us a very nice closed expression for this integral here.